Hi, welcome to HostDev 2022. And I will talk about contract testing for mobile application development. So this is me. Maybe you know me, but I can talk about a little about me. My name is Mesut. I think it's been more than 15 years, but for the first initial 3 years, it was about development and moved to testing area. You can find me in the social media and also on the internet with these ideas. Okay, so this is the contract testing and for the mobile part. So our topic will be around contract testing for mobile, integration testing, also mobile developments and mobile development process. And also it is the shift lefting is an aim, so I will talk about also shift lefting. And let's talk about the content. This is the content. As I said in the first few sections, I will define the mobile testing and also around the mobile testing, the mobile development process, and also contract testing. And the last part, it will be about the implementation of the contract test. You will find some clue about the implementation, but surely there are lots of details. So you can ask me anytime in the conference, during the conference, for those implementation details. Let's talk about the testing for the mobile app development. Maybe you can see test pyramid in everywhere, but this is a different illustration of test pyramid, and it also includes the testing types. And as you can see that testing type is also functional or non-functional. And we have also test levels. It is starting from unit level and integration also system and acceptance level. And our subject is, as you remember, it is contract test. And contract test is in the matrix. You can find it is non-functional and also in the integration level. It is why integration level? Because it's finally testing the integration of the system in. It can be anything that is integrating together. It can be unit integration, also component or system or anything. But in the contract test, we are not testing the logic or the user flow. So, which means that it is kind of static. So it is a non-functional testing. So this debate is something around this. So I can safely put it in this matrix as it is an integration testing and also non-functional test. So let's focus on the integration level. So referring to test pyramid, it is easier to explain the unit level and also the user or the system level. You know the unit level is finally focusing on the smaller part of the software. It can be a function or method to test it in an isolation. And when I come to the user perspective, and it is in the user perspective. And you know what the user does, you can define the specification and expectation. But when I come to the integration point, it is something hard to explain. The concept is wider. And also, integration is kind of inefficient. You can heard this maybe in some places. Or why it is, why it is inefficient? Because it is flaky. It is flaky because data management in microservices or the API is hard. You can think something like this. You have a project to test an API here, and also you are an API here. And there should be a network connection in between your project and also the API. And you can also think that this is an API. It's a box, but you need to test this. It is inputs, and it inputs maybe in the internal. There are lots of microservices, and there is also network lane in between the microservices. So it is flaky because if the error comes, you don't know where the error comes from or came from the big box. So it is also slow. As I mentioned, there's a network layer. And your API project here, API testing or the integration testing project here, and your project is here. And you are always checking the API endpoints to get to the correct answers from your big box. So it is slow. And also referring to data management, whatever data management approaches you are using, it depends on the network call. At the end, you can run an SQL command, or you can run a request to test data API management. So it is also a network. It requires also a network. So it is slow. And also, it is independent from the client. Maybe in the initial period, you create some tests regarding your users, but maybe there's an update on the user side, and you need to update it separately. So there is no direct connection between your users and the system, your API testing project. And so this is why the integration test is efficient. So how we can make it better? Actually, there are lots of things, but to apply to integration project with the integration testing, but there's a new approach that it's called contract testing. Let's talk about the contract testing first. What is contract? Literally, contract means that you have, it is a written document between you and somebody else. So when you are saying something and you are doing the same thing, then the contract is okay. So a contract is a written document, and it should be between two parties or more. And also, it's a written form. This is literally means. So what is technically means? So when I come to the technical means, we should have provider and consumer. The consumer is the one part that is consuming your services or APIs, and the provider is the one owns the whole system or the API. So that's the technical meaning, and it is a written document, and you can see that a simple JSON file. You can see the consumer, provider, and the interaction. And interaction means that the expectation from the consumer. And yeah, technically it is also easy to understand. So what is contract testing? So I come to contract testing with the definition of the contract. Checking the contract in the isolation. And it is a whole TDD approach to the system, which means that you are doing a contract, creating a contract, and then running your system against the contract and failing. And then you are writing another another implementation and running your contract, and it passes. So it passes. So which means that the contract is driven your full testing period. The keyword, I talked lots about this, but the contract is, as I said, is the specification from the consumer, and the consumer is the one who consumes your services, and the provider who owns the API, and also the broker. The broker is the places where you put your contract. And there are different kinds of contract testing, and the first one is provider-driven contract testing. Provider means that the provider owns everything. It creates the contract, it runs the verification, and then it updates the contract. So it is not defining the contract every time, depends on your consumer. It is good for public API. So you create an API and everyone can use it. It kind of there wouldn't be any expectation from the client, but from the development perspective. But there will be lots of input from the from the community. So this is the driven, provider driven, and the second one is consumer driven. I think the most important one in our speech, in my speech, the contract, consumer driven contract test. The consumer driven contract test is the consumer creates everything and it derives all the contract testing process. So in this process, contract will be always update, because the contract is the things that drives the system. And then consumer and also the provider checks the verification point in isolation. So it is faster, and it is also convenient. But dependency to the consumer might be difficult as a pros. And contract testing tooling. Unfortunately, we don't have much tool in the market, but the well-known one is Pact, and also we have Spring Cloud Contract Test. Both are open source, and we can use both of them. But the Pact is widely used because of it has lots of implementation. And let's talk about contract testing for mobile apps. So basically, if we are talking about the contract testing, then it is depend on the architecture that you have. Mainly, we might have monolithic, or we have microservice environment. And monolithic, as you can see in the left, it is a one box, and everything is inside, and the client is connected. But the microservice is something is different. It is a new approach. So let's talk about more the monolithic side. So it is only one repo, one languages, and one pipeline. And the client is on the out of the box. So when I come to the contract testing, where we can apply the contract test, the integration point is happening on the connection between the bugs, the API, and the client side. It can be web, mobile, or the API communication. So this is the monolithic. It is easy to implement, but it is hard to maintain. And another one, the new one, actually, the microservice environment. So with the microservice environment, every single responsibility can be put different project, and it can be just single responsibility, and then it can be independently deployable and independently testable. So with these approaches, there will be API gateway between your system and the clients, and then you can the client can use the API gateway to interact with your system. And bingo! Now we have lots of integration points and lots of things for the contract test. The integration can be happening in between the microservices and also between the API gateway and the microservice, also client and the API gateway. So testing these kind of things might be harder when I compare to the monolithic system. So you can see that the question is that who is the consumer, who is the provider? Maybe we can remember that the consumer is the one who consumes the API, the service, and the provider who is owns the system. And let's go to the implementation part. And the implementation with Easy App. This is a dog app. And since the dog app is dogs are very simple animals, and they have simple functionality. You can see that sleep, walk, and play. And you can see the contract map on the right side. It is very simple map. When I compare to a big microservice environment, let's say 100 or 1,000 microservices, then it will be very complex. But this can be an example to illustrate the whole system. So when on the app, when I click on the sleep button, then it will send a request to sleep endpoint. It will be GET request, and my expectation is to returning a JSON data that is containing the dogs who wants to sleep. And so this is a simple, and you can see the map on the right. And just clicking on the sleep button, and then it goes to the sleep microservice. And samely for the walk, again, I am clicking on the walk button, but this time it is using the walk endpoint, and it expects to a JSON with including the dogs that want to walk. But you can see the map there. Any walk who wants to walk should be registered. So there's a connection between dog and register microservices. As you remember, this is the integration between two microservices, and the testing this point should be handled in the contract testing between two microservices. So it is not in the context of testing the mobile app and the application, mobile app and your microservices. So in this example, we will just responsible of testing the integration between dog app and dog walk microservice. So, and this is a clue about the implementation part. How we can implement? Implementation should start with setting in the mock. You can see the mock service red in the middle with the green circle within this green circle. So, as a base, contract test requires consumer and the provider. So mock service should be dependent on this one. So with the mock service, I should define the provider and also consumer. And in this example, the provider is a dog app. The provider is the sleep service, but the consumer is the iOS app, the dog iOS app. And this is the specification, how we can implement the specification. So as you remember from the contract, I will use a specification regarding the sleep endpoint. I should send a request to, I should send a GET request to sleep endpoint by defining the provider state. The provider state, you can see that upon receiving a request for sleeping is a state. And this state is the provider state. So when the provider runs this test, it should check the state first. And if it receives a request for sleeping state, then it will create a data regarding this test. So those data should be prepared for this state only, and then it will consumed during this test, and it will destroy it after this test. So it is important. And then, as I said, it is the GET request, and the path should be the sleep endpoint. And I should also set the header, and will respond with is the expectation from the provider. And what should I expect? The status code should be 200, and then header should be like this, and the body is the JSON, is a JSON with the dogs. So the last part, I am running the contract test with the test complete. So dog app service should run, and then in the same fallback, I should call the sleep with my expectation. And the very last part of the test, I should call the test complete method, fallback method, because the test complete fallback method does this. It checks the result. If the result is okay, then it creates a contract, and then it pushes the latest version of the contract to Packbroker to keep always up to date the Packbroker. And this is the last part. And we will create. We are just creating the contract. In the beginning, what was our request is just getting sending a request to GET endpoint to sleep endpoint and expecting a JSON data. And our contract is something like this. You can read in there. And finally, we created the contract to make the whole picture. The provider should run the contract. So in the first part of the provider implementation, I should implement the PEC broker. And then it should pull the contract with the latest version and then run the test. As you can see in the last part, it should run the verifier. If the verifier is okay, then in the PEC broker, everything should be fine. And it should be set the verifier status. And this is the PEC broker. And then you can see the whole map that we have in the beginning. So there's then dog register endpoint. Sorry, there's a dog app, and dog app just sending the other requests to other microservices. Yeah, that's all. Thank you.
Thank you too for the presentation. So far you have 2 questions from the audience.
Yeah.
Do you have any specific advice for teams using WebSockets and message queue technologies?
Oh yeah, I think this is another debate in the PEC community that how we can test these technologies, but there is no implementation yet. Maybe we can follow the news from the PEC community and then find a good solution for it.
Okay, 5 likes. Do you really need a specific tool to do contract testing?
What?
Here, do you really need a specific tool to do contract testing?
Yes, we are using PECT for contract testing.
Okay.
So without a tool, you need to handle everything in your site. You are creating a contract by creating a JSON file and then putting it somewhere in a common place. Then you can pull it from there, from the provider, and then you can test it. If you are ready for this one, you can use it. Otherwise, you need to use PECT or Spring Boot example.
Okay. How does maintainability look like with API versioning?
Oh yeah, PECT is very good in this part. Because you can use your hash as a version. For example, in the consumer side, there's a hash, and then also there's a provider and there's a hash. If those 2 hashes are matched and all the verification are passed, then those are the stable version of your test. If not, then you can do another fixes and then fix the failing things, then creating another version. Yeah.
I'm absolutely not able to say that word. So what is the most effective way to test GraphQL?
Yeah, GraphQL.
Yeah, I know. I was just joking.
Yeah, this is also the same. It is still under investigation how to PEC community should implement a solution for this. Yeah, we should follow that community.
Okay, it seems that we don't have any more questions for you, so you're free to go and enjoy the following left of the day. Ladies and gentlemen, Masood Gunesh, thank you so much. I hope